So find the area between these two trig functions. It'd probably be a good idea to take a look at the graph. So sine of 2x and cosine of x, the window is from 0 to pi. Those are going to range between -1 and +1. Okay, so for the area between them, that's going to be this area right here, as well as this area right here. So you might say, well, these are symmetric. This shape right here and this shape right there are symmetric. Oh my, we actually need to find this area that's between them, and this area is between them, because it didn't say the order really. It didn't say that's the has to be the first one, that's the second one. It just says between. So what we're going to need to do is a couple of integrals. We'll need to integrate in here up to that point, and then they switch roles, so we would have to then switch them and integrate in here. And then because it's symmetric, this and this are going to be the same thing, so we could just double the answer. So one thing we need to do is find out where that is. I could set up an equation and solve it, and I might do that for some extra fun, but let's see, this is pi, so this is half of pi. So right here would be a quarter of pi. No, it's not going to work out that easy, is it? Pi divided by 4. No, that's at the top right there. That's not where they intersect. So one thing I need to do is find that. So set them equal to each other. When does sine of 2x equal cosine of x? And then use a trig substitution for the sine of 2x, namely 2 sine of x times cosine of x. And it's tempting to divide out a cosine, but if cosine ever equals 0, you would be dividing by 0. So instead, move this cosine to the left-hand side. And then factor out the cosine. Once it's factored, set the factors equal to 0. So this right here takes care of that case. What if cosine was equal to 0? Back here when I said maybe you would think about dividing by cosine, but what if cosine's equal to 0? And then this one would say, when is sine equal to 1/2? So cosine equal to 0, this would be 2 pi, in the middle would be pi, so that would be at pi over 4. And when does sine equal 1/2? So 1/2 would be right here. We could use the calculator to find out sine inverse of 1/2. Is that many pi's, and if you divide that by pi, you'll see that it's 1/6. And if you go back to the graph and check that point right there, trace a pi divided by 6. I don't know if you can see it, but it is flashing right there where they intersect. So x equals pi over 6. Is there still a glare? So if we go back to the graph, we need that point right there, which is pi over 6. Let me just change the window. Okay, so pi divided by 6 is that point right there. And then we need that one, but that's easy enough because the whole interval is pi, so that should be pi over 2. Okay, so we need the pi over 6, this was beautiful information, but we don't need it. We need that, and there we go, pi over 2. So first of all, we'll integrate from 0 to right here, which is the pi over 6. And whichever function that is, it's going to be that one minus the bottom one. So we can see that right here, it's the top one is cosine, the bottom is sine of 2x. So it's going to be the top one minus the bottom one. So we need to integrate from 0 to pi over 6, integrate the top one, which is cosine of x, minus the bottom, which is sine of 2x. And then we're going to have to do the second integral and add the two answers together. But we'll just do this one first of all. So the antiderivative for cosine is sine of x. The antiderivative for sine is cosine of x. But this one is cosine of 2x. So if we were taking derivatives, we would need to multiply by 2. Since we're doing the opposite, then divide by 2. Or if you use u substitution, you'll end up with the same thing. Then evaluate from 0 to pi over 6. So we'd have sine pi over 6. I happen to know that that's a half because that's where we got the pi over 6. Plus cosine, let's see, a 2 pi over 6 is going to turn out to be pi over 3. And divided by 2. Then substitute the 0. So minus, it's going to be sine of 0 plus cosine of 0 over 2. So we've got a sine of pi over 6, and then a cosine of pi divided by 3, which then gets divided by 2, minus, so sine of 0 is 0, cosine of 0 is 1, so it's really just minus 1/2. So all of that turns out to be just 1/4. And then next, we need, so this area in here is 1/4. Next, we need to find out this area. So that's going to be, switch these two. So it's going to be sine of 2x minus cosine of x. Let me just verify. In here, the top one is sine of 2x, so it's got to be the top one minus the bottom one, with x going from, so it's pi over 6, right there's pi over 6, and right there's pi over 2. And then the antiderivatives are going to be for this, let's see, it's going to be negative cosine of 2x, and then that's got to be divided by 2. And then this one's going to be negative sine of x. And then evaluate that from pi over 6 to pi over 2. So when you substitute the pi over 2 in here, it becomes just a pi. And then divide cosine of pi by 2. Next, minus sine pi over 2. And now substitute the pi over 6. So with a pi over 6 in here and a 2, it becomes pi over 3. And then divided by 2. And then minus sine of pi over 6. That's a lot of parentheses. Okay, so negative cosine of pi gets divided by 2 minus sine of pi divided by 2, and then subtract from that, parentheses, negative cosine of pi divided by 3, and then divide that by 2, and minus sine and pi divided by 6. Whoa! It's also a quarter. Okay, so we've got a quarter plus a quarter is 50 cents. So we've got a quarter plus a quarter plus a quarter plus a quarter. So 4 quarters would be 1.